Hello, hello, this is Chris, and we are just about to wrap up section 4 of SAT Practice Test 4. So we're in the grid ends now. We're going to take a look at questions 31 through 34. And let's go ahead and dive right in. And if you don't already know this, just keep in mind that the question difficulty does reset when you get to the grid ends. And the reason that's important to note is that as a test taker, you don't want to get lost in question 29 or 30, the hardest multiple choice questions, and spend too much time there running out of time for potentially easier questions to come. So as a testing strategy, that's always very important, especially on test day where we're under that time pressure, to make sure that we keep actively in mind. With that, for 31, it says a partially filled pool contains 600 gallons of water. A hose is turned on and water flows into the pool at the rate of 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? So starting with 600, and then water's flowing into the pool at 8 gallons per minute. How many gallons after 70 minutes? Okay, so this is going to be our constant. 600 is what we're starting with. And then water's flowing into the pool. That means we're adding water. And it's 8 gallons per minute. So that's our rate times our number of minutes. That would be 8m as a variable, but in this case they tell us 70 minutes. And that's it. So it's what we started with plus what we're adding. 8 times 70 is 560. 600 plus 560 is 1160. If you're not comfortable with the math, keep in mind this is the calculator section. All right, tackled 31. Let's go ahead and look at 32. The normal systolic blood pressure, P, in millimeters of mercury for an adult male, X years old, can be modeled by the equation P equals X plus 220 over 2. According to the model, for every increase of 1 year in age, by how many millimeters of mercury will the normal systolic blood pressure for an adult male increase? So they're asking how much of an increase we're going to have. And for every increase of 1 year, so this is basically like saying that your value of X goes up by 1. So the relationship between the pressure and X is going to be based on slope. And I know it doesn't look like it right here, but I highlight this time and time again. It's really important for test takers to internalize this. Look for that slope-intercept form relationship in equations that you're given. That should be something we're actively looking for, because although this might not look like y equals mx plus b, or slope-intercept form right now, let's see if we can divide each of these terms by 2 and display this a little bit differently. This is the equivalent when you have a numerator with x plus 220. You can actually divide each term individually by 2. This is the same as saying x over 2, or 1/2 x, plus 220 over 2, which is 110. And now, all of a sudden, it looks a lot more similar to our slope-intercept form. And we can tell that if we're looking for a rate of change, so your rate of change, whenever you're dealing with slope is a rate of change, and your rate of change will be your coefficient on your x term, which for this is 1/2, and that's our correct answer here. So here, for each year of increase in age, then they're asking for the blood pressure increase, and that's going to be equivalent to your slope in this expression, which is 1/2. So again, there's no calculation required here, so long as we can accurately recognize that this is an application of our slope-intercept form. Up next, we'll take a look at question 33. The pes, a Roman measure of length, is approximately equal to 11.65 inches. And I don't know if it's pes or pez, but I like Pez the candy, so I'm going to call it Pez. So here they give us a unit of length and a conversion factor. And then they say it is also equivalent to 16 smaller Roman units called digits. So also equal to 16 digits. Based on these relationships, 75 Roman digits is equivalent to how many feet to the nearest hundredth? Okay, so a lot of units here, probably some that we're not very familiar with, like the pes or pez, and then these Roman units called digits. So how do we do dimensional analysis or conversions, or like it's the same thing that you might have seen maybe even in like a chemistry class if you're doing stoichiometry. We're doing unit conversions, and the key with unit conversions is you always want to start with the given value. So we're going to start with 75, and they're called Roman digits, so I'm going to just put RD for our purposes here, just to make it a little bit easier. So this is what we're starting with, and then we're going to multiply by some sort of conversion factors, and we don't know how many of those we'll have to do, but we might have to multiply by a few of those, and ultimately our goal, we want to end up with a certain number of feet. That's our goal at the end. So we're going to go just one conversion at a time. So let's see what conversion we could make for digits. So it says here that the pes is also equivalent to 16 Roman digits. So one of these up here is equivalent to 16 RD. So that's our first conversion factor here. 16 Roman digits, 16 RD is one pes. And I'm going to just write this out so it looks a little bit neater down here. So we're still going to be left with feet at the end. So that's what we're looking for. That's our goal, a certain number of feet. Okay, so that's our first conversion. So now, and you can check with each conversion. You could either do them separately, which a lot of people do. I highly encourage you to get comfortable doing them all at once, but just making sure that you're canceling out the appropriate units as you go. So here, Roman digits would cancel out. So now we'd be left with the number of pes. And then our next conversion that we can use is they told us that one of those was equivalent to 11.65 inches. So here, one pes is equivalent to 11.65 inches. And when you're deciding whether you should write these conversions with a certain unit in the numerator or denominator, just keep in mind that you always want your denominator to be the unit that was in the numerator of the previous fraction so that it can cancel out. Because remember, our goal is we're doing unit conversions. So to convert means you cancel out the old units to put it in terms of a new unit. Now, when we do all this multiplication, we would be in terms of inches. But the question's asking how many feet. And so our last unit conversion, they do give it to us, which is very nice, but hopefully that's one that we know because it's pretty common. So here, our last conversion, there are 12 inches in a foot, and we want to put inches in our denominator to cancel out the inches. And 1 foot, it's equivalent in our numerator. And if you look, those inches will cancel out, and we will be left with the desired unit of feet. So again, whatever they're asking for, in this case, they're asking how many feet. So you want to do your conversions step by step with the appropriate canceling of units until you're left with the desired unit. And then we can just multiply straight across the top and straight across the bottom. So here we're going to have 75 times 11.65, and then we're going to divide that by the product of 16 and 12, and when you plug that in, you get 4.55, and they want it to the nearest hundredth, so we're going to include all of those digits. Let me just squeeze this in. It'll be a little bit small, but that'll give us 4.55 feet. And that's what we'll grid in as our correct answer here on 33. All right, last question on this page is number 34. In a study of bat migration habits, we have 240 male bats and 160 female bats that have been tagged. And then they say if 100 more female bats are tagged, how many more male bats must be tagged so how many more males? So it's 3/5 of the total are male. Okay. So a lot of numbers here, and it's kind of tricky the way they lay this out. So this question's starting to get a little bit more difficult as we get to the middle of our grid-in section. But here, the way they lay it out, they say our initial numbers are 240 male and 160 female. So if we jot that down, it's 240 male, 160 female. And then they just change that number that they gave us for the female bats. So they say, well, what if 100 more female bats are tagged? So when we get here, it's really like they have told us that we have 240 males and then 260 females. We've added those extra 100 females. So it's a little bit tricky the way they present that. Instead of just giving a number of males and a number of females to start, they add on that second number of females after the fact. So we want to make sure we get that right up front. And then let's see how many more male bats must be tagged. So we're going to be adding a certain amount to the males. We want 3/5 of the total to be males. So this as a ratio is going to be males over our total. All right, and we're adding some number of males. We don't know how many, right? So we're going to treat that as our variable. We're going to call that x. But we want to set up our initial ratio. So I'm starting with 240 males. That's how many I have tagged so far. And then I'm starting with 260 females and 240 males for my total. So that's the total number of bats. Remember, has to be males and females together in the bottom there. So here I have my males over my female, or over my total. And now I'm adding a certain amount, and this part is really key. I'm going to color code this a little bit, but whenever you're changing a value in a ratio, it's important to recognize if you're just changing one of the parts, or if you're just changing the total, or if you're changing both at the same time. Here, however many more males get tagged for this study, so when I add x here, I'm also going to be adding that x down here because that's going to add to my total, right? If I tag 100 more males, then that's part of my numerator for the number of males, but then it's also part of my total number of bats. So that change, that addition of x number of males has to be applied to both the number of males and the total. Make sure to include it for both. And then here, this is equal to our desired ratio of 3:5. So again, everything that we have here is as a ratio. It's males over total. And now we just cross multiply and combine like terms and try to solve mathematically on this. So here we can simplify our denominator a little bit. 260 and 240 is 500. So we get 240 plus x over 500 plus x equals 3/5. And then we can cross multiply. So that will give us 5 times 240, which would be 1200 plus 5x equals 3 times 500 is 1500 plus 3x. And then to combine like terms, we can subtract 3x from this side, from both sides actually, to cancel it out and be left with 2x on the left. We can subtract 1200 from both sides to cancel it out and be left with 300 on the right. We divide by 2. And we get x equals 150. So there are, in this scenario described, 150